Hello everybody. We already have started Introduction to Euclid's Geometry, and we have covered the definitions and the axioms given by Euclid. Let us continue the topic by understanding the postulates given by Euclids. Let me tell you that there are in total 5 postulates given by Euclids. So the very first postulate is a straight line may be drawn from any one point to any other point. Let me repeat the postulate 1 for you. A straight line may be drawn from any one point to any other point. To understand it, let us try to draw a line. For drawing a line, we need a point for sure. Let us have the point over here. Let this point be point A, and we have one more point, that is point B. So the postulate states that a straight line may be drawn from any one point to the other point. Let us try to find it out whether it's possible or not. If I try to make a line from point A, so yes, it happens like this. Yes, there is a line, there is at least one line which passes from point A and B together, right? So this postulate lets us know that there is going to be at least one line which will pass between 2 points. So does that mean that there could be only one line passing through that? To understand it, we have axiom related to this postulate. Let me explain that to you. The axiom 5.1 states, given 2 distinct points, there is a unique line that passes through them. This axiom states that if we have 2 distinct points, there could be only single line, that is a unique line that can pass through them. To understand it, let us try to derive something. We have 2 points, let us have 2 points as x and point y. Right? We have 2 distinct points over here. Let us draw some lines passing through point x. There could be infinite number of lines passing through x, as you know that from a point there can be infinite lines passing through that point. But if I draw a line extending from here, I see that this line crosses point y as well. If I try to make some lines from y, so it looks like this. Isn't it? We have drawn certain number of lines passing through point x as well as passing through point y. So how many lines are there which are passing through these 2 distinct points? You're correct. There is only one unique line, this one, which is passing through both the distinct point x and y. So this axiom, by stating the postulate given by Euclid, states that any 2 points can have only single or unique line passing through them. I hope this is clear to you. We have more postulates to cover. Let us jump to postulate number 2 given by Euclid. If you look at postulate number 2, have a look. A terminated line can be produced indefinitely. Before this, let us understand what is terminated and non-terminated line. As you know, what is a line? A line is that which moves in both the ends indefinitely. That means it can be extended here and it can be extended in the other direction as well. But if I say that a line is terminated, that means I have taken a line which is having 2 endpoints, right? So if a line is having 2 endpoints, then I can produce it indefinitely. Producing means extending it on either sides. So since these lines are this line is terminated, I can extend it in this direction. I can extend it in this direction as well. Isn't it? This postulate states that a terminated line can be produced indefinitely in either of the directions. That means we can extend it to any length in the directions shown here. So postulate 2 is all about a terminated line can be produced indefinitely. Let us look at the third postulate. Third postulate states a circle can be drawn with any center and any radius. Right, guys? If I talk about circle, we know that circle contains a center and we have a radius which we draw around, we use to draw a path of a point around the center to form a circle. If we have to draw a circle, I can take this, and you know that this is the circle. I can change its radius. I can even extend it this side. So what is this? This is a circle. This circle must be having a center, and the center appears to be right over here. We can name it as O, and this is going to be its radius R, isn't it? So is there going to be a circle which is only of this much radius? No, right? We can have circle of any radius. If I try to compare it to you, you will find, look, this is another circle which is having a smaller radius. If I try to put its center will be somewhere over here. We can name it as P, and this is its radius R dash, isn't it? So we can have circle of any radius with any given center. This is postulate number 3 given by Euclid. Let us jump into postulate number 4. The postulate 4 states all right angles are equal to one another. First of all, please tell me, what is a right angle? Yes, you are correct. A right angle is angle whose measure is 90 degrees. Yes, correct. So if an angle is having a 90-degree measure, it will somewhat look like this. Let me show you a proper figure. I'll draw it by my hand. So this symbol stands for 90 degree, that is right angle. So if I name it, I can name it as ABC. So this is right angle ABC, isn't it? I'll write it like this: angle ABC equals to 90 degree. Let us make another 90 degree angle. Guys, is this also a 90 degree angle? It seems to be, right? Yes, it is a 90 degree angle, and let us name it as X, Y, Z. That means angle X, Y, Z is equal to 90 degree. So guys, isn't angle ABC and XYZ equal to each other as they both measure 90 degree? Yes. This whole postulate is about this thing only, that all the right angles are equal to one another, and it is understood since the right angle has the measure 90 degree, so all the right angles will have measure 90 degree and they are going to be equal to each other. So I hope this postulate is also clear to all of you. Let us jump into the 5th and very important postulate given by Euclid. Let me read it for you. It's a bit longer one, but you will understand it quite easily. Postulate 5 states, if a straight line falling on two straight lines, what am I saying? There is a straight line falling on two straight lines, makes the interior angles on the same side of it taken together. Let us also draw it. When we read it, let us also draw it to understand it better. The first line says, there is a straight line which is falling on two straight lines. So let us first make two straight lines. This is first straight line, this is second straight line, right? Let us name it as AB and CD. Okay, and then there is a line which is falling on these. So line could fall like this. Let us name it as XY. Okay, so this is a straight line which is falling on two straight lines. Now they make the interior angles on the same side. So if I look at it, you will see that we have somewhere around these many angles getting formed. Okay, 4 angles on this side and another 4 angles on this side. So if I look at these angles and analyze them, I find that these angles, this one, this one, this one and this one, these 4 angles are what? These are the interior angles as they lie in the interior portion of the two straight lines. So let us read the postulate again. If a straight line, this is the straight line XY, falling on two straight lines, that is AB and CD, makes the interior angles, that is this, on the same side of it taken together, let us number these as well. 1, 1, 2, 3, 4, 5, 6, 7, 8. So the interior angles are 3, 4, 5, 6, isn't it? So I am taking the interior angles on the same side. So if I say same side, that means on the same side of this line which is falling on these two straight lines. So angle 3 and 6 are on the same side, and angle 4 and 5 are also on the same side. Angle 3 and 6 are on the right side, and angle 4 and 5 are on the left side, isn't it? So we have to take them together. If they are less than two 90-degree angles or two right angles, then two straight lines, if produced, indefinitely meet on that side on which the sum of angles is less than 90 degree. Two 90-degree angles or two right angles. Let me explain it to you in a better way. These lines appear to be, parallel to each other. Let us make another line. Let us make another line and get to the fact. We have a straight line which has to fall on two straight lines. The straight lines could be like these, and this is another straight line falling on them, and let us make the angles. So this is angle 1, 2, 3, 4, 5, 6, 7, 8. So if I look at it, can you see that angle 3 and 6 are on the same side of the interior part of these angles? Definitely yes. And if I closely analyze angle 3 and 6, aren't they less than 290 degrees? They appear to be. If I look at it, angle 3 plus angle 6 is less than 2 times 90 degree. Isn't it? It definitely is. So if we read the postulate, it says if we produce this side indefinitely, the lines are going to be meeting at a point. If I try to draw it, you'll see it over here like this. Let me write it for you over here, that angle 3 plus angle 6 is less than 2 times 90 degree. That means if I try to produce it like this in its direction of propagation, it is going to meet at a point, and this is that point there where they are going to meet, isn't it? So let me read the postulate again for you. If there is a straight line falling on two straight lines and makes the two interior angles on the same side of it taken together to be less than 290 degrees, that means less than 180 degree, then if we produce these two lines on this side, they are going to meet at a point. If I produce it over here, will they meet ever? No, never. You will see that it is not going to meet. It is going to meet on that side where the sum of two interior angles taken together is less than 180 degree or two right angles. So I hope these postulates are clear to you. If I recall the postulates, how many postulates are there? There are total 5 postulates given by Euclid. We have discussed all of them. We are going to do some more questions in the next class. Thank you so much.